Early ideas about atoms have changed dramatically over time as scientists carried out new experiments and gathered fresh evidence. Each discovery led to a new atomic model, helping us understand matter in greater detail. The story begins over 2,000 years ago, around 400 BCE, with a Greek philosopher named Democritus. He suggested that everything in the universe is made of tiny particles that could not be cut any further. He called these particles atomos, meaning indivisible. Much later, in 1805, the English scientist John Dalton published the first scientific atomic theory. Dalton proposed that all matter is made of tiny particles called atoms, which he believed were solid, hard spheres. According to his theory, atoms could not be created or destroyed, and all atoms of the same element were identical. Towards the end of the 19th century, experiments suggested that atoms were not indivisible after all. In 1897, J. Thomson discovered a tiny negatively charged particle called the electron. This led to the plum pudding model of the atom, where electrons were embedded in a sphere of positive charge, like raisins in a Christmas pudding. In 1909, Ernest Rutherford tested this model using alpha particles and a thin sheet of gold foil. Most particles passed straight through, but some were deflected. This showed that atoms are mostly empty space, with a small, dense, positively charged nucleus at the center. Niels Bohr later adapted this nuclear model by suggesting that electrons orbit the nucleus in fixed energy levels, known as shells. His calculations matched experimental observations. Further experiments revealed that the positive charge in the nucleus is made up of smaller particles called protons. Then, in 1932, James Chadwick discovered the neutron, a particle with mass but no electrical charge. These discoveries led to the modern atomic model, which is still used today, and show how scientific understanding develops as new evidence is discovered.